All right, this is a video over exponential and log equations. This is a continuation from in class. So we're picking up on example 5. When you have two log expressions set equal to each other with matching bases here, essentially what you can do is just cancel these out and set what you are taking the log of equal and solve from there. So we can say 5x minus 1 equals x plus 7. And then this becomes a basic algebra problem. You need to move your variables to one side and your constants to the other. So I'm going to move my x's to the left. And then my constants to the right. And then you get rid of your coefficient by dividing it out. So if you can remember your log rules and shortcuts like this, a lot of these problems that look complicated can become quite simple. Algebra 1 problems. Here's another one to try. Now on this one, we're eventually going to do the same thing we did on the last example, but we have more than one log on the left side of the equation. We need to condense this first into one log before we can cancel out. So here, you have these two logs of the same base being subtracted. That means we're going to use our quotient property to condense. So remember, quotient property says when it's expanded with subtraction, you can condense it into division. So log base 6, and then the positive term is your numerator, and the one being subtracted, or the negative, this is your denominator. And nothing changed on the right side of the equation. Okay, so now we're to where we were on example 5. We have log base 6 on each side, and we can just set these values equal. Okay, and then we just solve algebraically. So I first need to get rid of this denominator, so I'll multiply by 5 on each side. I need to get my x's to the same side. Don't forget to bring down that negative with the 14. Was it negative? I take that back. It was a plus. That should be a positive. I knew that didn't sound right. Okay, make sure you got the question copied correctly. That's an easy mistake to make. So again, you end up with x equals 2. Okay. On this example, you only have a single log term. We have this natural log expression right here. So you're not going to be matching them on the left and right side of the equation to cancel. Okay, we're going to work this to try and get x by itself. So first we'll move this constant to the opposite side. We end up with 2 natural log of x equals negative 1. Get rid of the coefficient that's being multiplied, so I divide. Now, once you get to this point, we can't just cancel natural log out because there's not a natural log on the right side. To get rid of the natural log in this case, we need to rewrite in exponential form, and you need to remember your understood base of a natural log is e. So when you convert to exponential, e is your base. Okay, negative 1/2 is your exponent, and it's set equal to what you were taking the log of, so x. So I was trying to solve for x, and I have. So now you can go to your calculator and type this in. Okay, e is here above the natural log. It's the second function, so you hit second natural log, and then it prompts you to enter your exponent, so mine is negative 1/2. You can enter it as a decimal or a fraction. And unless otherwise specified, I'd like you to round to the thousandths. place. Make sure you are rounding correctly. A lot of people are still making silly mistakes in rounding. You want 3 decimal places, you look at the next to see does it round up, and in this case it does, so x is approximately 0.607. All right, for this example, we don't have a constant to move, but we do have a coefficient. So I'm going to get rid of that 2. Leaves me with log base 5 of 3x equals 2. And now I'm to the same point I was on that last one. Okay, this is a log base 5 instead of a natural log, but it's the same process for converting to exponential form. You have your base. What you're set equal to is the exponent. And this equals what you were taking the log of. 5 squared is 25. And then we get rid of that coefficient. Leave this as 25 thirds, so you have an exact answer instead of getting a decimal and having to round. All right, the last thing we need to talk about is interest compounded continuously. You need to remember this formula. A equals P times E to the power of RT. Okay, you'll hear this referred to a lot as PERT. Okay, A is the new amount. It's called A because that's the annuitized amount. That's a banking term. It just means the new amount after your interest is earned. P is the principal amount or the original amount, okay, that you're starting with in the account. R is your interest rate, and T is time, and time is going to be measured in years. So if you're given a problem like this, it says that we've deposited $500 into an account earning 6.75% interest compounded continuously. How long will it take your money to double? We know when we see that compounded continuously statement, this is the formula we're using. So we need to identify the key parts. So first, my initial amount, what I'm starting with, is $500. So remember, that is your principal, P. My interest rate is 6.75. Don't forget to change this, though, to a decimal from a percent. Remember, this is percent is out of 100, so divided by 100, or you're just moving your decimal 2 places. So this becomes 0.0675. That's what you're going to input here. Time, we do not know. That's what our question is asking us. How long will it take? Now, for your A, for your money to double. So you just have to double the original amount. So 500 becomes 1,000. So we'll plug these in. So 1,000 equals 500 times e to the 0.0675 t. And we're trying to solve this for t. Okay, now this looks similar to what we were just doing. Once you have it set up, we need to get rid of this coefficient 500 first. Now, we have to get our variable out of the exponent. To use power property to bring your exponent down in front of your term here as a coefficient, you have to have a log or a natural log. In this case, we're dealing with e, so we definitely want to use natural log. What you do to one side, you have to do to the other. So if I want a natural log the right, I had to natural log the left. Now that gives me opportunity to use power property to make this exponent a coefficient. And then you have to remember that the natural log of e is 1. You can just cancel it out, it's 1. Now we're solving for t. We need to get rid of this coefficient by dividing it out. Now this would be the time you would come and type it in the calculator. So you're doing the natural log of 2. Make sure you close this parenthesis before dividing. 0.0675. So that was 10.269 approximately. And again, this was in years. So this would take you, for your money to double, would take a little over 10 1/4 years. All right. Hopefully you're comfortable now working with those. We also have the examples that we went over in class, the first part. Make sure you bring your notes to class and are ready to work on the assignment.